All right, welcome back. Dr. P here, and we'll go ahead and start the Chapter 10 lectures. In this first lecture, we'll look at the nomenclature and structure of organohalides. So, organohalides sometimes called haloalkanes or alkyl halides. They all refer to the same thing. They are hydrocarbons that have halogens on them as substituents. So we have an alkane with one or more halogen substituents. Okay, an example could be this version here, which we would call iodomethane. It's also called methyl iodide. And when we're naming things, if we use the IUPAC nomenclature system, we're going to name our alkane like we did before. But we'll use the halogen prefix, the appropriate halogen prefix for the substituent. Thus, we can see here we've got what would be, if I cover that up, if I put a hydrogen there instead, that would be a methane. But I have an iodine here, so that's iodomethane. So our abbreviation, not our abbreviations, our prefixes are fluoro for fluorine, chloro for chlorine, bromo for bromine, and iodo for iodine. We could look at, let's say, another example here. So here we've got a chlorine and we have a methyl group, and we've got 1, 2, 3, 4, 5 carbons. So that would be pentane. And we'd start numbering at the end closest to a substituent, which of course the chlorine counts as a substituent. So this becomes 2-chloro 3-methyl pentane. And actually now we've got 2 chiral centers, so we probably have to figure out R and S, but we're not going to deal with that right now. Now we could have common names as well. Okay, and the common name in this case is methyl iodide. Let me just underline that. So a methyl iodide is the common name. And here we're going to name the alkyl group then name the halogen and we're going to use the suffix "ide." So this would be 3-methyl pentyl 2-chloride. It's a little confusing. So typically we only use the common names for simpler alkyl halides. So, iodomethane, dichloromethane, you know, chlorocyclohexane, things like that. All right, so that's nomenclature. And I do want to say a few things about structure. So let's take a look at some structural features. You know, I do want to mention just two others here that have common names that you may run across. So dichloromethane is also called methylene chloride. And then trichloromethane is called chloroform. And you could have, you know, with 3 bromines, it would be bromoform. 3 iodines would be iodoform. So these are a different type of common name that you will, let me spell that correctly, methylene chloride. There we go. These are a different type of common name, chloroform, for example, that you may run across. But again, we typically use the common names for the simpler alkyl halides. All right, so let's go back to talking about structure. Let's start talking about structure. And typically, our haloalkanes here, our alkyl halides, will have some polarity associated with them. So if I take a look here, and let me grab a purple pen here, my chlorine is more electronegative than my carbon, so I have a net pulling of electron density towards the chlorine. So I get a partial minus there and a partial positive on the carbon. And this is true for all of the halogens. So even ones like iodoalkanes, alkyl iodides, even though the iodine, its electronegativity is not as great as that as, let's say, chlorine or fluorine, it still leads to a polar bond, a bond that is polar. Interestingly, if we have chloroform, and oh, I just messed this up here. I'll do it like this. I'll redo it. There we go. How about that? Cl. If we have chloroform, now I've got 3 polar bonds here. And then I'm going to end up with a delta minus at this end and a delta plus at that end. I'll have a net dipole moment. Here my net dipole moment is going that way towards the chlorine. Here it's also going towards the chlorine. And these actually end up having the same dipole moment because you've got 3 chlorines, which is a greater electron withdrawing, but due to their geometry, they each just contribute a third of what they would in, let's say, chloromethane. So that's something important to remember, that the CX bond is polar. Put in my lone pairs. And of course, X is often what we use as an abbreviation for any halogen. Okay, so X equals a halogen. So that's one thing to keep in mind, and especially as we go into chapter 11, the polarity of that bond is important. Now, there's some other things. So maybe we'll say types of alkyl halides. If our halogen is just attached to a methyl group, that's a methyl halide. If the carbon that the halogen is attached to has one alkyl chain, that's primary. We abbreviate that with 1 and a degree sign. If we have two alkyl groups attached to the carbon that the halogen is attached to, that's secondary. So it's like naming carbocations. And then if we have three alkyl groups, that's tertiary, which is 3 with a degree sign. Now we can also have some others. Let's see here. Well, maybe I'll just write them down here. We could have a vinyl halide, where the halogen is directly connected to a carbon that's double bonded to another carbon. We could have a single bond in between, and that's an allylic halide. So we have halogen, single bond carbon, double bond carbon. So with the vinyl, that's directly attached to the halogen is directly attached to a double bonded carbon. With the allylic, the halogen is attached to a carbon that is then attached to the double bonded carbon. We could have a phenyl halide, and we could also have a benzyl halide. And so again, the phenyl is kind of like the vinyl, where the halogen is directly attached to one of the ring carbons. With benzyl, the halogen is attached to a carbon that's attached to the ring carbons. So those are some different types of alkyl halides, different classes, if you will, different ways of categorizing them. And we will see that in the next chapter, chapter 11, there are this type, methyl primary, secondary, tertiary, allylic, benzylic, those can affect how these alkyl halides react in substitution and elimination reactions. All right, in the next lecture, we'll take a look at some ways to prepare alkyl halides. But until then, stay safe. Bye now.